Okay, we'll just kind of draw what we are picturing is happening.
Yeah.
That helps me. So then we'd have two aqueous just means it's like in water, right? And so if just one of these fell apart in solution, that's what we'd have, right?
Yeah.
Okay. So it's just kind of nice to like picture what's happening. They're telling us it's a strong electrolyte, and if they want us, we're trying to find out how much of each ion we have in solution. If after this all dissociates, we're left with was it 5.5
Yeah.
molar solution? Okay. So this one really isn't too bad.
Okay.
So
Good.
I say that now. So let's just look back at our definition of what is molarity.
Okay.
And it is the number of moles, right?
Yeah.
Per what?
Per liter or volume.
Per liter or volume, yeah. We could change this. So.
I think so far it's always been liter.
Yeah, liters is the kind of the standard. The one that I like working with liters a lot more, but number of moles per liter. Okay. And it wants us to break down the molar concentration of each ion, right?
Right.
Okay, so do you think that we should total, when it says number of moles, does it mean number of moles of this, or number of moles of this, or number of moles of both of those added together?
I don't know. So ask that again.
So, because molarity is the number of moles per liter, right?
Right.
So are we going to say that it's the number of moles of ammonium ions or sulfate ions? Or both of them together? I think both too. When I asked you that, I was like, I don't know if I know. Let's just do both, and we'll see if it makes sense. And
Okay.
we come out to be right. So if we assume it's both of them together,
Right.
how many ions is this?
3.
You get 3 ions for every one of these molecules that dissociates, right? So that would be, if we just looked at molar ratios, you'd have a 1:3 ratio, right? For every one of those, you get 3.
Yeah.
So, we're told that our final molarity, 0.55, 0 molar. So, or moles per liter. So then what if we just tried, if we're saying, if we're doing it total to see if that's the right way to do it, couldn't we just divide that by 3?
By 0.55 is 0. To get moles, you mean? Or to find the liters?
Not the liters. So, sorry. So if we have 0.55 moles, or it's 0.55 molar, right?
Right.
But we know that's moles per liter.
Right.
But we know that there's really 3 ions making up that 0.55. So if we divided 0.55 by
No.
3,
Tell us
it
the
would give us,
molarity of each ion. Or,
that's kind of what I'm thinking. And then we times this one by 2 since there's 2 of those.
yeah.
And that one would just be 1.
Right.
I don't know. This
Okay.
might be totally wrong. So 0.55 divided by 3 would be
0.183 repeating.
okay. So if we said we had 0.183 moles of this and of 2 times that. Does that make sense?
Yeah.
So I don't know, you have the right answer. Is 2 times that what the concentration for ammonium was? Or no?
No,
Okay.
but I think that might be like somewhere close or something because, so, I don't know.
Ah, okay. No. Okay.
This
So we were.
You want,
That's no. I see what we did. Okay.
Yeah.
We're not. We shouldn't look at it as them added together. We shouldn't have divided it by 3.
okay.
Man, I hate when you have 2 choices and you choose the wrong one and it's wrong.
Well,
So.
if you're me, you chose the wrong one 3 times, or 2 times, you got the 3rd time right.
Well, okay, so I'm trying to think of a good way to explain this. It's so hot in here.
I can pull up the solution and see how they explain it. I don't know.
Yeah.
Maybe if we go
That-
together, I don't know.
Yeah, maybe do that because I'm just trying to find a good way to word it.
So it says ammonium sulfide dissociates in aqueous solution according to, and there's the formula, which is what we had, right?
Mm-hmm.
Therefore, the solution is 2 times 0.550 equals 1.1. So it's just a molar ratio kind of thing, basically.
Mm-hmm.
And 1 point, and the cation and 1 times 0.550. Yeah. See, I don't see that, like, looking at the problem, and I think that's what mainly worries me, is like getting that problem on the test, and
Yeah.
like, or one similar to it.
I think. Oh, okay. Sorry, okay. So we have 0.55 molar of this compound.
Okay.
And it is like what we were just talking about in a 1-to-3 ratio. So if you have 0.55 molar of this, you know it's going to completely dissociate. For every 1 mole of this that falls apart, you get 2 moles of that. If you double the number of moles, you haven't changed the number of liters, you haven't changed the amount of solvent. So it makes sense you would just double the molarity. Right?
Yeah.
And this, just 1-to-1 ratio. I don't know why I wrote 1-to-3 up there still. This one, so 1-to-2 and 1-to-1. So since this falls apart, but you still get 1 mole of this, it's just gonna have the same. I think I misread it and I thought it was saying that the final, like, dissociated it was,
Right.
I don't know. Anyway.
Well, that's kind of how it sounds, but.
And it might technically I think it probably is, but I think it's better to think in terms of if you have this much of this.
Right, and then we haven't changed, like you said, we haven't changed the volume of the solution, we've only changed the number of moles because we dissociated.
Right. Yeah. Does that help?
Yeah.
Okay.